Welcome to the very first lecture of the chapter Set Theory. In this video, we would be learning about what are sets. We would be learning about their definitions, and at the end of the video, we would also learn about some of the special, sets which would be used throughout the course. So let us get started with what are sets. Sets are defined as well-defined collection of objects. So what do we mean by well-defined? So here, this terminology well-defined here means that they should have the same meaning for everyone. Let me write it down. Have the same meaning for everyone. So whenever I talk about a set, there should be a clear picture in your mind what are the elements of it. So that should have the same meaning for me as well as you. Then only we can call it well-defined. Next, it's well-defined collection of objects. So collection basically means group. So we have a well-defined group of objects, and these objects are called the elements of the set. Most of the times objects are denoted with small letters, and the sets are denoted with capital letters. Right? So as we have understood that sets are well-defined collection of objects, let us also see how we can represent that a particular object is a part of a set. So I have to erase it. So here, if X is an element of set A, if X belongs to A, we write it as X belongs to A. So here, this is the symbol we use to denote belongs to. So if X is a part of set A, so here we have this small letter X is a part of this set A. So X is an element of set A, then we write it as X belongs to A, right? So this thing X belongs to A, so this is what we call belongs to. And if we write it as this, if we cut this sign, then it will become does not belong to. So here, if X does not belong to A, we write it as this. So this just means that X doesn't belong to A. So X is not a part of A. So let us take a few examples to understand what a set is. So for example, A is set of first 5 natural numbers, right? So A is the first 5 is the set of first 5 natural numbers. So what comes to your mind? What are the elements of it? So the elements could be 1, 2, 3, 4, 5, right? So these are the first 5 natural numbers. We all know it. It's well defined, right? Whenever I call the first 5 natural numbers, it should come to your mind that it's 1, 2, 3, 4, and 5, right? So what we can say? We can say that 3 belongs to A, right? So here we have A, and these are the elements of A. So we can say that 3 belongs to A because we have here 3. Also we can write 5 belongs to A, right? So this is the set A, and here 5 is also a member of set A. So 5 belongs to A. Also we could write 8 does not belong to A, because here you can't find 8, right? So 8 is not a part of A, and that's why 8 does not belong to A. Let us solve a question to understand more about the sets. These are the statements that are given to us, and we have to recall if these are sets or not, right? So the first statement is the collection of vowels in English alphabet. Is not it well defined? Whenever I say the vowels, every one of us understand that it is A, E, I, O, U, right? So it's well defined. It's for me and for you, it holds the same meaning. So definitely it's a set. Next is the collection of first 3 prime numbers. Whenever I call this particular statement, that is the collection of first 3 prime numbers, what am I saying? What am I referring to? I'm referring to 2, 3, and 5, right? that has the same meaning for me as well as you, and that's why it's well defined and it's a set. Now the statement is the collection of most dangerous animals in world. Now this particular terminology over here, most dangerous, it's quite ambiguous, right? What might be a dangerous animal for me might not be a dangerous animal for you as well. Some people are afraid of dogs. For them, dogs are dangerous, but for others, they might not be dangerous, right? That's why it's quite an ambiguous term, most dangerous animals in world, and that's why it's not set, since it has different meaning for different people. But on the other hand, when we call the collection of all animals in a zoo, it's a set, because it's well defined. In a particular zoo, it's well defined what are the animals that are present in that zoo, and that's why it's a set. Next, the collection of good teachers in a school. Now this is another ambiguous term. What are good teachers for you and me? Might be my favorite subject might be mathematics, and that's why a good teacher for me would be a maths teacher. But for you, might be your favorite subject is geography, so for you the best teacher might be a geography teacher. So it's not well defined, right? So it's not a set because it has different meaning for different people. On the other hand, when we talk about the collection of all teachers, in a school, that's a set because it's well defined. In a school, it's already defined who are the people who can teach in a school, and that's why it's a collection of well defined objects, and those objects are the teachers in that school, right? So here we solved a quick question. So now, as you have already got the idea about what sets are, let us understand some special sets that we would be using throughout the course. So these are some well-defined sets which have been assigned these notations already, and we would be using them extensively throughout the course. So here first we get n, capital N. Capital N here represents the set of all natural numbers. The set of all natural numbers are 1, 2, 3, 4, and so on till infinity. So the set of natural numbers include 1, 2, all up to infinity, right? Then we have this capital Z. Capital Z over here represent the integers. So what are the integers? It comes from minus infinity to -3, -2, -1, 0. Then again it goes to infinity, 1, 2, 3. And then towards infinity. So it comes from minus infinity, all the numbers, and then again goes to infinity. Next, when we write this small plus over the Z sign, it means the positive integers. The positive integers are also the natural numbers, so these are just 1, 2, 3 till infinity. So whatever integers, the integers that are greater than 0 belongs to the set of all positive integers. Next comes capital Q. Capital Q represents the set of all rational numbers. So what are rational numbers? Rational numbers are the numbers which can be represented in the form of P by Q, where P and Q both belongs to the set of integers. So whenever a number can be represented in the form of P by Q, where P and Q belongs to integers, then this is a rational number. For example, let's say 2 by 3 minus 4 by 7, 0, all these are rational numbers, right? Next, when we put a plus sign over it, we understand all the rational numbers which are greater than 0, right? So these are greater than 0. Next comes the capital R. Capital R here represents all the numbers that are present on the number line. It might be rational, it might be irrational, doesn't matter. All the numbers. So let me write any number on the number line belongs to this set of real numbers. These are real numbers. Next one is R plus, right? This plus, small plus, represents all the real numbers that are greater than 0. So all the positive real numbers. Next comes this C. Don't worry if you don't understand it. This is the set of all the complex numbers. Which complex numbers are those numbers which can be represented as a plus ib, where a and b are real numbers. So don't take it too heavily right now, because you will have a complete chapter on complex numbers afterwards, so you would have a better idea what complex numbers is. To get a brief description, complex numbers contain both real numbers as well as imaginary numbers. So that's it. These are the special sets which we are having. So in this video we have learned about the definition of sets, the way we can represent an element to be a part of a set. We have also seen some examples which we can call sets and which we can't call sets, and some special sets.